Dynamics, impact, problem solving. A bullet with the velocity v hits centrally an initially resting frictionless supported board of mass m. It penetrates the board and has thereafter the velocity v2. Determine the velocity w of the board after the penetrating shot if board of mass equals 8 times mass of the bullet, and v2 equals v divided by 3. To solve for the velocity w of the board after the bullet penetrates it, we apply the principle of conservation of linear momentum. The conservation of momentum principle states that if no external forces act on a system, the total momentum of the system remains constant. Given mass of the bullet m, initial velocity of the bullet v, mass of the board m equals 8 times the mass of the bullet. Velocity of the bullet after penetrating the board v2 equals v divided by 3. Before the collision, the bullet's momentum is m times v and the board's momentum is 0 since it is initially at rest. After the collision, the bullet's momentum is m times v2 and the board's momentum is mass of the board times w. Using the conservation of momentum, m times v equals m times v2 plus mass of the board times w. Substitute the given values into the equation. M times v equals m times v divided by 3 plus 8 times m times w. Solve for w. W equals v divided by 12. Therefore, the velocity w of the board after the bullet penetrates it is v divided by 12. Thank you for watching. Please do not forget to subscribe if you like this video.